Welcome everyone to this session on using or not using reactive streams in Java 9. I'm happy that I'm not alone here because that's the last session today. My name is Jacek Kunicki. I work at Software Mill. We are a software consultancy based in Poland. We write code like most of you here do, probably, but there are two things that are unique about Software Mill. First of them is that we are remote, and it's 100% remote, so we don't have offices at all. And the second one is that we have a flat structure, which means we don't have any managers. We are fully transparent, including financial transparency. So if you're interested how it works or how it doesn't work, feel free to catch me after the talk and discuss it. Today we're going to talk about JDK and the reactive streams support that is there. So let's start with a quick recap of what reactive streams and what stream processing is. There was already one introduction during Johan's talk about akka streams, so if you attended it, this will be like boilerplate. But anyway, well, stream processing is basically about processing data, so you need to have some kind of producer of your data. You need to have some kind of a consumer, so the place where your data ends, and you have some intermediate stages that do some kind of processing of your data. And of course, you have data flowing from the producer through the stages to the consumer. And now, if you think about this architecture, this use case, there can be some problems when the downstream, so for example the consumer, is slower than the upstream, which is the producer. And then in this situation you have some excess data with which the downstream is not able to cope. And there are certainly there's a number of strategies which can be used to deal with this excessive data. The simplest one is probably just to drop the data. And this is actually not something very unusual, because if you think, for example, about networking hardware, it often happens that the excessive data is just dropped. You can, for example, block, so the consumer, the slower party, can block, but then you lose all this like asynchronicity, and basically the entire pipeline is blocked when the consumer is blocking. The consumer can also buffer the data, and when it comes to buffers, well, they are good until they are overflowed, because if the buffer has always a limited capacity, and if the consumer is really slow and the producer is really fast, then actually the buffer can overflow. You will run out of memory. So the other way, and the best way that we want to use to deal with excess data, is called backpressure. And backpressure is basically a way for a slower consumer to tell the producer to slow down. So this is like some kind of data that is sent upstream, so in the opposite direction than the actual data. And it's a way for a slower consumer to tell the producer how much data it can accept. So it's basically a way for slowing down the producer. And this is like a general naming for stream processing pipelines. Of course, all the implementations have their own naming. So in JDK, the interfaces, well, the producer is a producer, so this is pretty simple. The consumer is called a subscriber, and the stages in the middle are called processors. So this is like stream processing in general with backpressure, but what makes reactive streams special? Because this is not yet reactive streams. So in reactive streams, the first attribute of reactive streams is that they're asynchronous. So all the processes of data sending are not non-blocking. So we have this asynchronicity. And then the backpressure itself is also non-blocking. So this is like the mechanism for consumers slowing down producers is realized in some kind of a non-blocking way. And this lets the CPU and or the operating system reuse threads when possible, because if the backpressure was blocking, we would have some threads that are blocked and cannot be used. But if the general processing is asynchronous and the backpressure is non-blocking, then the threads can be reused for some other purposes. The other important attribute of reactive streams is that slow consumers are somehow represented in the domain model. And I have two examples for those. First of all, it's like a bit higher level, so it's Twitter API. And actually, when you use Twitter API, it allocates some kind of a buffer for your connection, and it's sending you messages. But apart from the data messages, so for example, the tweets you are fetching, it can also, if it detects that you are consuming too slow, it can send you some notifications that, hey, you're consuming too slow, and if you don't speed up, we're going to terminate the connection. So this is like when using the API, you already know that being slow is somehow handled, is somehow represented in the domain, so in the API here. Another example is the Streams APIs, where you have something like a state called conflate. And conflate, what it basically does is when it detects that the downstream is slower, it aggregates the data. So when the downstream backpressures, it says it's like too fast. The conflate starts aggregating the data, and only when the downstream becomes fast enough, it emits the aggregated data downstream. So like I'm not going to dig into the internals of this, but this is another example that like the designers of the API have already thought of a situation where the consumer can be slow, and this is represented in the APIs here. So starting from JDK 9, the interfaces for all the reactive stuff have landed in the JDK. So they are now the part of the JDK. You don't need to have any additional library like the org reactive streams jars. It's inside the JDK in the java.util.concurrent.Flow class, and the interfaces are there. So let's now have a quick overview of what the interfaces are. So the first one, like starting from the beginning of the pipeline, is the publisher. And it's a pretty simple one because it basically produces elements of some arbitrary type which the downstream is then going to consume. And it can have subscribers registered via the subscribe method. And that's pretty much it for the publisher. Then on the other end of the pipeline, we have the subscriber. And the goal of the subscriber is, well, to subscribe to the publisher to receive data. And actually can receive different types of data. So first of all, it can receive a confirmation that the subscription was successful with the onSubscribe method. It can receive items via the onNext callback. And there are actually two more callbacks for handling like what happens within the stream. And those are the onError callback for errors and onComplete to signal that the like source or the producer is complete, and then there's basically no more data. So having a producer and a subscriber, we need some kind of link between those two. And this link is called a subscription. So subscription basically connects a subscriber to a publisher. And it allows to do two things. First of all, it allows for backpressuring. So subscription is the place where the actual backpressuring takes place. And for this, we have the request method, which can request an arbitrary number of elements from the producer. And then the subscription can also be used like as it is a link between the producer and the subscriber. We can use it to cancel the subscription, so say that we don't want any more data. There is also something called a processor. So processors, as you may remember from the initial slide, are the intermediate parts of the pipeline which do the actual data processing. And actually, processor is nothing more than a combination of a subscriber and the publisher. So it implements those two interfaces and, like, so to say, exposes both behaviors. So the typical way of a stream processing pipeline to work is that you have you call subscribe on a publisher. So you have a subscriber and you connect it to a publisher with subscribe, and then the subscriber receives a single onSubscribe callback. Then it can receive an arbitrary number of onNext callbacks to receive data, and eventually it can receive either the completion signal or a number of error callbacks. So now, since most of you here are developers, I suppose, when you see such simple interfaces, the first thing that comes to your mind is probably to implement it. So let's actually try to do it and try to implement those interfaces and see how easy it is. So what we are going to do now is trying to implement a simple publisher that is just going to have some iterator of integers, and it's going to, like when a subscriber connects, the publisher is going to emit the data from the iterator to the downstream, so to the subscriber. So, like the most naive approach, when you have, first of all, we need to implement the publisher interface, which has a single subscribe method, which needs to handle a subscriber that is connecting. So, in the very naive approach, we'll just take all the data from the iterator using the for each remaining. And for each of the item, we're going to call subscriber on next to send the item to the subscriber. And then when we exhaust the iterator, so when all the data is sent, we're just going to complete the subscriber, so using the onComplete callback. So this looks fairly simple. Let's see whether it can work at all. To test it, we need a main method, and we need a new instance of our simple publisher. Let's say we want to emit 10 elements, and then so that our elements can be consumed, we need a subscriber. So we are calling subscribe using a new subscriber. And here are a couple of methods that need to be implemented in the subscriber. We're not going yet to implement the onSubscribe, so that's a subscription. We're going to deal with the incoming data using onNext and just print the data that arrived. We're going to do something similar with any errors that possibly happen. So it's just a dummy way of printing them to the standard output. And it's pretty similar when it comes to completion. We're just going to print that it's complete. So now what we did, we took our simple publisher that basically takes the iterator and sends all the data from the iterator downstream to the subscriber, and we connected like a very, very trivial subscriber, which just prints the data it receives. It doesn't do any backpressure, it just prints out what comes to it. So let's now try to run it. And you can see that, well, at first sight, it works like expected. So the subscriber received all the data because the iterator contained 10 elements, and so all the data is here, the completion signal is here. So what can go wrong? But actually, it turns out that implementing all the interfaces in the Reactive Streams in the Reactive Streams package is not that easy. And if you wanted to try to do it yourself, you should use something that is called the TCK, which stands for Technology Compatibility Kit, and it's basically a bunch of tests that check whether your implementation satisfies all the requirements for a like working and correct Reactive Streams implementation. And the TCK is available, so the tests in the TCK are available as a library, which you can just like throw into your project and then run the tests against your implementation. So we have one test here for our simple publisher. It extends some Flow publisher verification, which comes from the TCK. So now let's try to run it and see what happens. And you can see that, like, apart from a single test that was green, all the others are red. So, as you may expect it, our trivial and naive implementation of the publisher isn't really the best one, so it couldn't be used to be connected to other like building blocks of Reactive Streams. Because the goal of the TCK is basically to check whether your implementation is going to work correctly when connected to other implementations of the Reactive Streams. So this one is not going to do it. So let's have a look at the errors that we have here and try to fix some of them. So, for example, the requirement number 1.09, because there is like an invisible dot there, tells us that we need to call onSubscribe. And this you remember when a subscriber connects. And you may remember this from the basic flow. So after a subscriber connects to a publisher, it receives an onSubscribe callback. So we didn't implement it. So let's try to do it and see if it fixes anything. So we're going to fold the main method because it's not necessary anymore. And now, so having the subscriber, we need to call the onSubscribe callback. And here you see that we need the subscription. So it was obviously missing. And subscription, as you may remember, is the link between a producer and the subscriber. So we need to create one here. So since we're doing simple stuff here, let's call it simple subscription. And now what we're going to do is like move all the communication with the subscriber to the subscription, because as you may remember, the subscription serves as a link between the producer and the subscriber, so we're moving all the communication with the subscriber there. So therefore we're going to pass the instance of the subscriber to the subscription. So let's create the class here. Let's store the subscriber in a field. And then, since we're implementing subscription, the interface, we need to also implement the methods that are there. And there are two of them. First one is request for handling the backpressure, and second is cancel for handling the termination of the pipeline. Okay, so now we are in a situation where a number of elements was requested. So we are expected to emit this number of elements that comes here downstream to the subscriber. So like the initial idea that I'm going to start with is just to create a for loop. We'll have a variable called demand, and we're going to initialize with n, so the number of elements we need to emit. The stop condition would be, well, the running condition is that the demand is greater than 0, and also that the iterator is not empty, because if the demand was greater than the number of elements in the iterator, then it doesn't make sense to emit anymore. So we're going to add iterator has next here, and we're going to decrease the demand. And then once again we're going to call subscriber on next, as we did in the first naive implementation. And the argument is going to be iterator next, so basically the next element. So this is about sending the elements downstream, and then after we send the n elements downstream, we also want to check whether there is any more data in the iterator. And if there is no more data in the iterator, we want to call subscriber on complete to signal that the sending is complete. So we're going to check whether the iterator has any. If it doesn't have any more elements, we're going to call subscriber on complete. So once again, what we did here, the first change that we did was introducing a subscription, so the link between the subscriber and the producer. And then by implementing two methods, well, actually we only implemented one of them so far. By implementing request, we are responding to the demand that comes from the downstream. And basically we're sending some number of elements from our iterator to the subscriber. And then if there are no more elements in the iterator, we're completing. So let's run the test again and see if it helped. Well, some more of the tests have passed. You can see that 109 has passed, so at least we fixed that, but there are still some tests that are failing. So let's see if there is anything more that we could easily fix. So when you have a detailed look at the other failures, you have 309, which says that if 0 or a negative number of elements are requested, we need to signal an error. So this is an invalid situation, so we need to handle it. This sounds pretty easy to implement because we just need to add an if here, and if n is less than equal to 0, we need to, So initially you would think we need to throw an exception, but actually throwing exceptions is not the best way to signal errors in a streaming pipeline. For signaling errors, we have the on-error callback, so that's actually what we need to do. So we need to say on-error, and let's say we want a new illegal state exception here. So now running the tests again, we can see that, there is even more of them that are green. Specifically, oh, sorry, we want illegal argument exception, not illegal. No, we need illegal argument exception, so it hasn't passed. So let's put illegal argument exception here and see it once again. Now the 309s are green, so we've just fixed another one more thing. But it's still not perfect. So let's have a look at some other errors. For example, we have 105 or 107, which if you read the error message that we received an additional complete signal, well, this has something to do with the termination, and perhaps with the we don't handle the termination properly, so we don't handle some state, and therefore we are signaling too many times. So that is going to be the last one that we will try to fix. So to fix termination, we need some internal state, like an internal flag to store the information whether we are terminated or not. And since we need to be thread safe, we're going to use an atomic boolean for that. We'll call it terminated. And initially it's going to be false because initially we're not terminated. So now there are several places where we need to use it. Well, the first and the most obvious one is perhaps the cancel method. So when we receive the cancel signal, we need to set the terminated flag to false, so that we store the fact that we have been terminated. so we call set false. And now we have to somehow use the flag in our request method, like so to consider the information when sending the data downstream. So the first place to check it is in the for loop. So apart from the demand being greater than 0 and the iterator being not empty, we also want to check that we have not been terminated yet. So it's not terminated.get. Oh, yeah, you're right. Yeah, that wouldn't work. Thanks. Yeah, and now the other place where we need to check it is also when checking the iterator for emptiness here before signaling on complete, because actually the error we got from the test was about signaling completion incorrectly. So what we want to do here is also check whether we have not been terminated. But also what we want to do, like when we cancel, we actually need to set, if we have not been terminated yet, we need to cancel and set the terminated flag to true, because to signal termination. And actually, instead of calling like two methods, so get here and set in the body of the if clause, we have an atomic method for that, which is called get and set, which basically gets the value, which will be used for comparison in the if clause. And then after extracting the value, it's going to atomically flip it to another value. So we're going to set it to true. So once again, what we did here, we introduced some state for storing information whether we have been terminated. Since we need to be thread safe, this is an atomic boolean. When we receive the cancel signal, we're setting it to true, and we're reading it in two places. First of all, it's before emitting any element, and then before completing the stream. And here, when we decide to complete the stream, we actually also setting the flag to true. So after running the tests again, we can see that they look much nicer. So only two of them are left that are, apart from the ignored one, which result from the fact that we're not fully implementing the tests. So that's why some of the tests are ignored. But from the non-ignored ones, there are only two that are failing now. So actually, when you have a detailed look on the messages, it turns out that we are starting to approaching some non-trivial problems. Because, for example, here, 303 tells us about infinite recursion or unbounded recursion, which basically results from the fact that the message is that it must not allow unbounded recursion. The problem is that our implementation is synchronous. So what we are doing in request, we are synchronously calling on next. And actually, usually what a subscriber does when it receives the on next callback, it handles the data which was sent but with on next, and then calls request once again to receive further data. So we're ending up with a like chain of calls from on next to request, then to on next, and this is infinite recursion. And actually what you see here in the other error, although it's about something different because it's about handling like very huge demand, like long max value, here you can see that this is the result of our unbounded recursion because we got a Stack Overflow here. So to sum up the challenges we've ended with so far is that like first of them is the unbounded recursion, so that which results from the fact that we are synchronous, and then there is like infinite calls to request on next and request. And then you saw the other error, which is about infinite demand. And this is also not very easy to solve because, for example, if we fixed it to run asynchronously, so if we emitted anything downstream in an asynchronous way, so in a thread, then when we receive demand for max value elements, the long max value, we would certainly run out of threads because, well, you can, depending on your machine, you can allocate a number of threads, but definitely not max value. So this would be a problem. Also, if you thought about like just storing the demand somehow and accumulating it, then if you just stored it in a long variable and if you incremented it in a multi-threaded environment, you could easily get a number overflow basically. So the conclusion here from trying to implement this single interface, so notice that we just wanted to implement a publisher, which is not the simplest, but also not the most complicated one. Actually, the processor is the most complicated one. The conclusion is that you rather shouldn't be doing it. unless you're authoring a library that is going to like fully implement the reactive streams concept, and then unless you take care to run all the TCK against your implementation and make sure that all the tests pass. And as you saw, like we started with some trivial problems, but then we got to some more complicated ones. So it's really not that easy as it may seem from the interfaces. So you may ask yourself, why are the interfaces there in the JDK if you shouldn't be implementing them daily? So the answer is that the goal of the interfaces is to serve as something called SPI, which stands for Service Provider Interface. So if you look at the particular WOS, this is an interface for service providers. And service providers are basically implementations of the reactive streams. So this is basically meant to connect different libraries that expose the reactive streams interfaces. And actually now we'd like to see like what's the state of like streaming support in the JDK, what could be done in the future. So if you look at things that we already have in the JDK since a very long time, perhaps, there is a couple of them that like either sound or even behave like streams. So for example, we have input and output streams for the Java I/O. We also have iterators, which, well, may not be like really a stream, but it exposes a behavior similar to streaming because it's like it can handle infinite data, and then it doesn't send everything at once, but it's like sends element by element. So this you may think of it as a bit related to streaming. We also have the new I/O with the channels for accessing files, for example. Actually, in Servlet Spec 3.1, I think we have some async support coming in the form of read and write listeners. Then we have Java SQL, which has the result set, and a result set is usually backed by a cursor in the database. So this is also like kind of a streaming behavior, because once again you don't send everything at once, but send you react to demand somehow. Of course, starting from Java 8, we have the streaming API, which is not reactive, but it exposes the streaming behavior. And finally, we have the java.util.concurrent.Flow interfaces starting from Java 9. So there is a number of abstractions, as you can see, but actually each of them is implemented in its own way, and there is no like unifying layer among them. So you're really not able to connect them easily. So even if you, for example, want to transfer data from one file to another using the output streams, so the like very basic abstractions for I/O, you need to allocate a buffer yourself, and you need to like read the data to the buffer, then write it to the file. So this is, and it doesn't expose any of the reactive behaviors like non-blocking backpressure. And in an ideal world, we would like to be able to use the single call, the publisher.subscribe, to connect a subscriber to a publisher. And this call is pretty important because it does all the magic underneath. So basically, well, it connects the two things, but it handles the non-blocking backpressure. So it handles the situation where the subscriber is slower than the publisher. It also handles errors, for example, with the callbacks. It handles termination. So a lot of things that you don't want to be able to, you don't want to think about when just connecting two things. So this gives a lot of magic, but it's really not there. So now I'd like to have a like quick look about the futures or what you could be dreaming of to have in the JDK. So the things that I'll be showing now are not yet there or are just partially included in the JDK, but those are like nice to haves. And actually, before we go there, I wanted to talk about what is not in the JDK. So you only have the interfaces. So as you saw, there are those 4 interfaces, but there is there is a single implementation which is called Submission Publisher, but it's actually not a good one, and you also shouldn't be using it because it's synchronous. So it really doesn't play well with the asynchronous concepts of reactive streams. We don't have any like basic combinators for handling streams. So if you know any reactive libraries like Akka streams, like Project Reactor or RxJava, there are operations like filter, map on the streams that let you somehow manipulate the data, and we don't have anything like that in the JDK. And there is actually an initiative from Lightband called Reactive Streams Utils. And Reactive Streams Utils is basically about providing an interchangeable implementation of the reactive streams in the JDK. So the assumption is that there will be some minimum set of operations, like I said, like filter, map, flat map, and stuff like that. But then you would be able to like choose the implementation of the other ones from a library that could be like just defined by a system parameter. So if you wanted to use Akka streams, you could just use Akka here, but you could as well use Project Reactor, RxJava, or anything you choose that implements the reactive streams. So now coming back to those nice to have, so what it would be cool to have in the JDK. It's, for example, the HTTP. So HTTP, we have some async support, as I said, in the server.io 3.1. And actually, there is a reactive HTTP client starting from JDK 9. If you've already used JDK 9, you may not yet noticed it because it's in the incubating package, and it's still incubating in JDK 10, but hopefully it's going to make its way to the non-incubating packages. And it supports, for example, something like supplying a publisher of data to a post method. So basically, having a publisher of your data, you could make a request, a post request to a server, and then just give it a publisher, and it will take care of sending the data with the backpressure and with all the magic that you would like to have. So if, for example, the servlet request provided also a publisher for the body, so if you received a servlet request with a file upload, for example, and if you are able to have a publisher of the data, then you could do something like that to just send the file to a remote server. So this would be just like using the post method with the publisher taken from the servlet request. But unfortunately, the servlet request doesn't support a publisher yet. So as I said, this is a future that we would like to have, but you cannot really be sure whether it's going to be there or not. Another example is database access. And there is an initiative in the JDK called ADBA, which stands for Asynchronous Database Access API. This is basically something like an async JDBC. And the works on it are pretty advanced. They were even trying to implement all the reactive interfaces, but as far as I know, they unfortunately needed to drop support for the publisher subscriber interfaces because it was too hard to implement. So although there is like ADBA is going to be there, it's probably not going to support the reactive interfaces, which is a pity. There are some existing drivers for various databases, but they are vendor specific. They are not like unified within the JDK. So you could use them for a particular database, but there is no like general solution. And if you took JPA, for example, so now if you want to have a list of entities from the JDK, you create a query and call get result. But it would be really nice if you, for example, instead of just getting the result, you could get a publisher of the results coming from the database. So then you could just have your database and abstracted by JPA as a reactive component that you could be able to for example, connect to the reactive HTTP client, and then using just the subscribe method, so just creating the reactive connection with a single call, you would have all the magic, all the backpressure, dealing with different speeds of the endpoints, and you would be able to use it to, for example, stream data from the database to some other endpoint. But once again, just to remind, it's not yet there, so it's something that would be nice to have, but it's not really certain as of today whether anything like that is going to exist. There are some more things as well. I already told you about the example of, for example, transferring data from one file to another. And if you had if in the I/O package you had something like a publisher of bytes for reading the file and subscriber of bytes to writing to the file, then instead of, for example, allocating the buffer yourself, you could just call subscribe and connect those two and transfer the data from one file to another with all the fancy reactive stuff. There could be, for example, JMS, which is also about some kind of asynchronous communication. So if we had like reactive interfaces for JMS, it would also be nice. You can also think of WebSockets, which once again is an example of async communication over HTTP this time. But there is, it would be really nice if it like fit in all the unified APIs. So if you had different building blocks, all of which expose the same API. And actually, there is some incoming support for reactive in the AWS SDK. But the problem with the AWS SDK is that they are using the reactive interfaces internally, but they are not exposing it to the clients or to a developer. So if you used the AWS SDKs, there are some like methods for file uploading, for example, to AWS, and they may be using the reactive stuff inside, but as of today, they are not exposed to the outside world. So this is like a partial solution, so to say. There is also Alpaca. It was mentioned in Johan's talk, and Alpaca is basically a set of connectors that can be used to Akka streams. You can think of it like a reactive camel, because camel is the library for integration, or at least it used to be. And Alpaca is also like a set of connectors, similarly to camel, but it implements all the reactive interfaces. So you can do the integration in a non-blocking fashion, contrary to what camel does. And Alpaca is actually there, so you're free to use it. But then it would be nice if you just could have something like Alpaca, so something like an integration layer using the reactive interfaces in the JDK, because now it's like the matter of adoption of all the features, and whether the new interfaces, the reactive interfaces in JDK are going to be adopted or not. It really depends how easy to use they are. So we have like, we covered some stuff that it's not there. We covered some stuff that it would be nice to have there. But it's not here yet. But it would really make it easier to adopt all the interfaces. So now I'd like to show you a simple example of integration, of integrating different implementations of reactive streams. But since none of the like I/O building blocks are there, so well there is this HTTP client, but there's really nothing more. What I want to show is how to connect different implementations, like different libraries that use reactive streams together. So what we are going to do is we're going to take the Flux from the reactor as a publisher of our data. We're going to use a flow from Akka streams as the processor of data, and then we are going to use RxJava to consume the data. And actually, there's one more thing I forgot to mention when it comes to adoption. So basically, there are like two worlds. You have the world of Spring, and you have the world of Jakarta EE, which is the new name for Java EE, if you didn't know. And then there are like people who would like Java EE to adopt all the reactive stuff, because there are still a lot of companies who are using Java EE, and they would really benefit from it. But on the other hand, there is Spring, which internally uses Project Reactor, as you saw in the previous talk. So the Spring people are really not interested in adopting all the reactive stuff in the JDK or in the Java EE, because well they already have it, and there is no reason for them to drop Reactor. But on the other hand, there are companies that use Java EE and would really benefit from it being in the JDK. So coming back to the integration example. So what we have here. Let's start from the building blocks that we have here and how they are connected. So as I said, we have a publisher coming from the reactor. Then we have a processor which comes from Akka streams. We connect those two using subscribe. And then we take the flowable, which comes from RxJava, and we take data from the processor and then consume it with subscribe by just printing it to the system output, to the standard output. So if you look at the factory methods for those components, the publisher is indeed a Flux. So we take a Flux that emits numbers every single second, basically. So nothing fancy here. And you can see that we are using some like glue code that exists in Project Reactor that converts the interfaces, basically. So Reactor has its own interfaces. It has mono, Flux, and things like that. But then we need to convert them somehow to the java.util.concurrent.Flow once to be able to connect it together. So this is what JDK Flow Adapter is here for. And similarly, if you look at the Akka Streams processor, this one indeed uses the Flow API of Akka Streams. And what it does, it's basically going to negate the number that was emitted, so that we are going to emit negated numbers. And once again, we need to use some glue code to convert the interfaces between the Flow to a processor. And actually, when it comes to Akka Streams, it's a bit less trivial than with Reactor, because you can see some materializer here. You can see an actor system here. So this is some logic that is specific to Akka streams. And basically, Akka streams makes it is like explicit about providing runtime for your streaming pipeline. So you define the pipeline, but then you need to define like a runtime, so an environment for it to run it. And this is the materializer, which is based on an actor system. So there are some additional steps that you need to do to actually convert it to these reactive interfaces. And now if you run it, well, 0 is not negated because it's 0, but the other numbers, you can see that they are negated. So this is like a simple proof that the integration actually works. And once again, just to remind, like we have components taken from different implementations of reactive streams, from Project Reactor, from Akka streams, from RxJava, but we like lift all of them to the java.util.concurrent.Flow interfaces. So all the communication that occurs here is through the reactive interfaces that are here in the JDK. Now there is some error because we are like abruptly terminating it, but we really don't care. So to summarize, first of all, as you must have noticed, there is really nothing like a full reactive streams implementation in the JDK. So you only have those 4 interfaces: the publisher, subscriber, a subscription to link those two, and the processor, which basically is both a subscriber and the producer. The goal of them being in the JDK is not to be implemented like daily by regular developers, but it's rather an integration layer for different implementations. So if you wanted to write a library, you should be exposing those interfaces, but you really shouldn't be writing the components yourself, but rather use something that was like thoroughly tested. And as you have seen, implementing it on your own is really not non-trivial. We tried to implement a publisher, which I said is like somewhere in the middle when it comes to complexity. So the subscribers are easier, but the processor are the most complex ones because they need to be asynchronous and there is a lot of stuff you need to think. But if you wanted to implement a library yourself, which you are free to do, of course, then you really need to remember about using the TCK, which is like it's a pretty extensive one. And if you go to GitHub, there will be a link, and you will see there is really a bunch of rules that you need to adhere to, and you need to use the TCK to verify that your implementation, when connected to other implementations, is going to behave correctly, so that it's going to fulfill all the contracts required by reactive streams. There are some resources for you to have a look if you wish. So the first one is the pluggable runtime from Lightband, the Reactive Streams utils. This is the TCK I mentioned, so if you want to see how non-trivial it is to implement it, please just have a look at it. There is a blog post about ADBA, which is the async database connectivity, like the async JDBC. And as I said, unfortunately, probably they are not going to support the reactive interfaces, but well, who knows? And there is a nice blog series about advanced reactive Java. So this basically covers stuff like if you really wanted to implement some of the interfaces yourself, what you should look at, what pitfalls there are. So this is really a nice place to have a look at. So that's all I had today. If you have any questions, please, you can, well, ask now. I think we still have some time. Well, this is the end of the conference, but I'll be around here. I'll be grateful if you took some time to vote in the application, especially if you didn't like something. So there's a text field to provide feedback. I would really like to improve the talk if there is anything to improve. So please take a minute to give some votes. Thank you very much.